Okay, Assalamualaikum warahmatullahi ta'ala wabarakatuh and good day everyone. So today is our week number 12 asynchronous class. Okay, and we are going to start with a new chapter number 5, which is differential equations. This also means that we just left with 2 topics to complete the syllabus. This is the second last, all right? And for your information, this chapter 5 does not take as long. Perhaps, okay, we'll see. Okay, within this synchronous lecture pun maybe kita boleh habiskan syllabus ni, because actually differential equation is quite a very big topic as well, macam different macam derivative. Okay, but for your course, okay, engineering maths 1, we just concentrate on first order differential equation only. Alright, for the second order we just discuss it generally, and we'll proceed second order in details in your engineering maths 2 course. Alright, so the followings here are the outlines for chapter 5, where we have solution of linear differential equations, separable differential equation, and exact differential equations and integrating factor. Okay, so basically differential equations. Okay, what is differential equation? Differential equation, nama pun differential equation, meaning that inside the equation we have the derivative. Okay, inside the equation we have the derivative. For example, we have equation 1 here, dy dx equals to fxy. Okay, it's equals to a function where it contains the variable x and y. So what you have to do, okay, with this differential equation is basically you are going to find the solution for this differential equation. Maksudnya kita akan cari what is the solution for this differential equation. What is the function y that when you differentiate you will get this differential equation. Something like that. Okay, y fx. Okay, when you differentiate the function you will get back the differential equation. So in order to solve the differential equation, you may need the derivative and the integration techniques that you have or that we have discussed in chapter 3 and chapter 4 respectively. Okay, so this is what I just explained is being stated here, in which fxy is a function of two variables defined on a region in the xy plane. Okay, so this equation 2 is another form of how we express the differential equations. Okay, all the three form can be changed interchangeably lah. Kalau you tak suka bentuk macam ni, you boleh buat equation 2 punya style, something. Okay, alright. So as I said just now, for this chapter, meaning we are looking for the solution of equation of the differential equation. Of equation 1 is a differentiable function y equals to yx, okay, defined on the interval I of x values, okay, perhaps infinite, that satisfy this one. Okay. So general, what we call general solution ni maksudnya is a solution that contains all possible solutions. Okay, all possible solutions. Sebab kita tak tahu the exact solution, then we consider it as a general solution. If you tak faham lagi, tak clear lagi what does it mean by general solution, doesn't matter, just hold, okay, just hang in there, alright, because we will explain it through example in a bit. Okay. Okay, so now let's have a look at example 1 here. Show that every member of the family functions c equals to c over y equals to c over x plus 2. Ini yang saya maksudkan tadi, which is considered as the general solution. Kenapa? Sebab c kat sini is a constant. Okay, and the value of c, dia boleh jadi any value. You boleh jadikan dia 4,000, 10, any value lah, positive or negative. Okay. is a solution of first order differential equation. dy over dx equals to sorry, dy over dx equals to 1 over x times 2 minus y on the interval. Macam ni dia dah cakap. Okay, on the interval 0 to infinity. Meaning that here we consider c is a positive value lah. Okay, on the interval 0 to infinity where c is any constant. So this question asks you to show, maknanya you have to prove that the equation ni, okay, or the solution ni, y equals to c over x plus 2, okay, it is the solution for this differential equation. dy over dx equals to 1 over x 2 minus y. Alright, now let's try to solve this example 1. Okay, so how we are going to show this? Alright, so biasanya kalau kita proof ni, we will show left hand side akan sama dengan right hand side. Okay, so you have two approach. So ada you nak work out from from y and show that is equals to dy dx, ataupun dari dy dx you work out buktikan yang you will get y ni. Tapi the second approach ni is actually the method that you are going to learn in the coming subtopics. Okay, so we use the first approach where we have the equation of function y equals to c over x plus 2. So from here kita cari dia punya dy over dx. Okay, so dy over dx of this will give us apa dia? Is equal to c x power of negative 1 tambah 2 untuk you nampak lagi clear. So differentiate c x power of negative 1, you're going to have negative c x power of negative 2, or is equal to negative c over x square, right? So in this case, you have this. Okay, dy dx is equal to negative c over x square. Tapi yang ni kita ada dy dx is equals to 1 over x times with 2 minus y. So this equation we have dy over dx. So now we have already our dy over dx is equals to negative c over x square. So we put in, katakanlah this is equation 2, this is equation 1. We put in this into equation 2. So we have negative c over x square. Okay, is equals to, ataupun saya patut buat macam ni lah. Okay, I write first equation 2 again. dy over dx equals to 1 over x 2 minus y. So our dy dx is equals to negative c over x square equals to 1 over x 2 minus, we know, given to us, y is equals to, okay, y is equals to c over x plus 2. So dari sini, if you try to work it out, okay, you try to work it out, so you will get 2 over x minus with c over x square minus with minus with 2 over x. Okay, minus with 2 over x. So you see, this one and this one you cancel. So with this, we have left hand side, which is dy over dx is equals to negative c over x square. And now your right hand side also you left with negative c over x square. So left hand side is equals to right hand side. So proven. Okay, maknanya this is the solution to this. Okay, where c, it can be any number. We do not specify. C ni dia boleh jadi 2 over x, okay, ataupun 10 over x. Okay, so this is so called as a general solution. Dia ada banyak possible solution. Okay, we done with example 1. Okay, so this example 2 show that the function y equals to x plus 1 minus 1 over 3 e to the power of x is a solution to the first order initial value problem dy over dx equals to y minus x. So, yang ni kita tak panggil general solution, okay? Sebab this solution is only satisfy for the differential equation dy over dx equals to y minus x for the case y0 equals to 2 over 3. Okay, so maknanya it only satisfy when y0 is equals to 2 over 3 for the condition where when x equals to 0, y is equals to 2 over 3. Okay, kalau you tak percaya, kita boleh buktikan kat sini lah. Okay, one of the approach that you want to buktikan adalah when we have the equation y equals to x plus 1 minus with 1 over 3 e power of x, right? So it's given to us the initial condition y0 is equals to 2 over 3. So maknanya when x sama dengan kosong, so you ganti kosong tambah 1 tolak 1/3 e equals to 0 is 1, right? So you will get what? 2 over 3 lah, sebab yang ni adalah 1 tolak 1/3. And given the initial initial condition as well, y0 ni adalah sama dengan 2/3. So nampak tak? Sama. Okay, so it satisfy that initial value condition. Tapi tu just untuk membuktikan that value is the correct value. But to show that it's a solution to the first order differential equation ni, kita buat macam tadi lah. Okay, where we have y is equals to x plus 1 over 3 e to the power of x. So differentiate dy over dx is equals to, differentiate x plus 1, you get you get 1. And then differentiate 1 over 3 e to the power of x. Remember, when we differentiate exponential, we just get back same thing. Sebab power dia ni pun just x kan, e power of x. So that is our dy dx. So now we are going to prove that it's going to be solution for this differential equation y minus x. So what you got to do is we gantikan lah, dy dx is equals to 1 minus 1 over 3 e to the power of x. This dy dx kita masukkan ke dalam ni on your left hand side, and your right hand side, our y tadi is equals to x plus 1 kan, x plus 1 minus 1 over 3 e to the power of x, then minus with x. Faham tak ni? Okay, maknanya yang ni adalah kita punya dy over dx. Lagi pula. Okay, and this one is our y kan. So because this dy over dx equals to y minus x. So if you can now on your left hand side is 1 minus 1 over 3 e to the power of x, and on your right hand side x plus 1 minus ni, yang ni boleh cancel dengan yang ni, betul tak? Setuju? Then you have 1 minus 1 over 3 e to the power of x. So again, left hand side is equals to right hand side. So it's proven. Done. Okay, example number 2. Okay, so example number 3 ni, okay, is slightly different. Tadi kita just discuss about first order differential equation. Now we move to second order differential equation. Tapi yang ni simple je lah, second order differential equation ni. Okay, because kalau tadi saya introduce to you the differential equation is in equation where we have the derivative inside the function kan, y prime plus with xy, okay, equals to 0 for example. Yang ni kita panggil first order differential equation because kita ada y prime sekali je differentiate. Okay, that's why it is so called as first order. Second order means we have double prime, y double prime plus 3y prime plus with 5 equals to 0 for example. Okay, since the highest degree of the derivative inside this differential equation is double, is the double prime kat sini, maksudnya dia adalah second order ataupun dua kali differentiate lah. Kalau you chapter 3 hari tu macam mana kita dapat second derivative kan, dua kali differentiate. So this is second order differential equation. Tapi untuk your course for this stage, you just need to know generally macam ni sahaja. Okay, we are not going to solve to find the solution for double prime because that one you're going to learn dalam engineering mathematics 2. Okay, so for this example, dia kebat lah sikit kat sini. Tadi kalau the first two example, we just discuss about the first order differential equation. Now we have show that the function y equals to e power of negative t is a solution to the second order differential equation. Now, fahamkan kenapa dia jadi second order? Because we have y double prime here. So, kat sini maksudnya, kita ada y equals to e to the power of negative t. To show that y e to the power of negative t is the solution for this differential equation, very simple. You just need to find, first we differentiate one time. So, differentiate e to the power of negative t. Ni tak nak discuss dah lah macam mana, kenapa dapat negative e to the power of negative t ni. Okay, we have discussed this thoroughly in chapter 3. And to get y double prime, meaning that you have to differentiate one more time from here. Then from negative, darab lagi dengan negative e to the power of negative t. So you get positif pula lah, e to the power of negative t. So having this, maksudnya kita masukkanlah dia dalam this differential equation y double prime. What is our y double prime? Is e to the power of negative t plus with 2 y. What is our y prime? Our y prime is negative e to the power of negative t. And what is our y? Our y is this, e to the power of negative t. So see what you get. E to the power of negative t. Okay, this one and this one, you can add them together. So you get 2 e to the power of negative t. And then this one, darab masuk, you can have 2 negative 2 e power negative 2. So, obviously, we get 0. So, samalah dengan soalan ni tadi. Okay, we get. So, from this, left hand side equals to right hand side proven. Alright, so that's it for the first part of the video for today's asynchronous lecture.